Esters are formed from the acid-catalyzed reaction between a carboxylic acid and an alcohol. The reaction is more commonly known as esterification. The mechanism is nucleophilic substitution, with the alcohol behaving as a nucleophile. In the first step, protons from our acid catalyze protonate the carboxylic acid, with electrons from the double bond moving out to form a bond to a proton, and from the OH group, a lone pair of electrons from the oxygen form a double bond between the carbon and the oxygen. The net result is that this carbon is far more delta positive and therefore more open to attack by the alcohol. So in our first intermediate, the oxygen from the OH group has a positive charge because it's now making 3 bonds. It's used up its lone pair. And the alcohol uses a lone pair of electrons from the oxygen to attack and make a bond to the delta positive carbon. In the next intermediate, we can see the new bond that's been formed between the alcohol and the carboxylic acid using that lone pair of electrons on the oxygen, and as a result, this oxygen is now carrying a positive charge because it's making 3 bonds. Oxygen can get rid of its positive charge by kicking out a hydrogen and keeping the electrons from the OH bond, restoring its lone pair of electrons. And we also see the oxygen from the original hydroxyl group of the carboxylic acid attack a proton to form an OH2 group. This is a really good leaving group, which does in fact leave in the next step in this mechanism, taking the electrons out of that carbon-oxygen bond. At the same time, so that the carbon continues to make 4 bonds, the OH group here uses its lone pair of electrons to make a carbon-oxygen double bond. In this final intermediate, we can almost see the ester. Our oxygen that made the double bond to the carbon using its lone pair is now carrying the positive charge. Once again, it's going to get rid of that positive charge by kicking out the proton and keeping the pair of electrons, hence restoring the carbonyl group for the carboxylic acid, part of our molecule, part of our ester, and also regenerating our proton, hence the acid is behaving as a catalyst. So our final product is methyl ethanoate. You'll notice that every step in this reaction is reversible, and the reaction will come to an equilibrium mixture of reactants and products unless we force it in the forward direction. Now, we can do this in 3 ways. We can add an excess of alcohol. We can use a dehydrating agent such as anhydrous magnesium sulfate to remove the water as soon as it forms. Or we can distill off the ester as it forms because the ester is more volatile than either the original carboxylic acid or an alcohol. You can find the notes for this video as well as lots of other really useful stuff at Crunch Chemistry. There's a link in the blurb below.